Hi guys, welcome to the KNN Project Solutions lecture. I hope you have already solved all the tasks without the help of this lecture. But still, we need to go through these tasks one by one. Let's move on and deal with these tasks one by one. So the first thing he is asking to import these libraries. Let's run this cell and then read this breast cancer diagnostic.csv file. Let's run this cell as well. And moving forward, create our data frame with selected features. So let's run this cell as well. So now we have data frame ready to work with. Get the overview of your data using info. Let's call df.info and run this cell. And here we have the same output. We have 569 entries and we don't see any null value in our data frame. The next task is which type of breast cancer is common. Let's call value count on diagnosis column. Let's move up and copy this diagnosis from here. Dot value counts and run this cell. Here we have 357 type B cancers and 212 type M cancers. So the next question is standardize the variable or features to get your data ready for KNN. Import standard scalar. We have learned that standard scalar is a part of pre-processing in Scikit-learn. So from Scikit-learn dot pre-processing, you can press tab for autocomplete, import standard scalar, and let's run this cell. No error, so this code is working. Create instance scalar. This is the same what we did in the previous lecture. So scalar equal to standard scalar and run this cell. We have created an instance scalar here. Split the data into features and target to fit the scalar to the features only. So our features equal to df dot drop, and we need to drop the diagnosis column. So let's copy this diagnosis and paste it here, and axis is 1, and then our target is df and the diagnosis column. Let's run this cell and we have features in this feature variable and target in this target variable. Fit scalar to the features now. Should be pretty simple again. So scalar dot fit and pass in features and run this cell. And here we have fit the scalar to the features now. The next task is please get the scaled features into scaled features variable. So scaled underscore features equal to scalar dot transform and pass in features. So we are calling transform on scalar now and passing the features and getting scaled features in this scaled feature variable. Let's run this cell. There is no error. The code is working. Do the train test split. This should be very simple for you now. So from Scikit-learn dot model selection import train test split, and then our x is equal to, we can pass in scaled features, and our y equal to target. So he's doing everything in one cell. X train and x test, and then y train and y test equal to train test split, pass in x, pass in y, and he's asking test size equal to 0.33 and random state equal to 42. Let's pass in test size 0.33 and random state 42. And let's run this cell. Once again, there is no error, so this code is working. The next task is import the k-neighbor classifier. Let's do this import here. So from Scikit-learn dot neighbors import k-neighbor classifier and run this cell. The next is asking for create a KNN model instance with n underscore neighbors equal to 1. So our KNN equal to k-neighbor classifier and pass in n neighbors equal to 1 here. And let's run this cell. Once again, the code is working, there is no error. So now we have instance. Fit the model to the training data. Let's use this knn.fit and our training data is xtrain and ytrain and run this cell, and here we have trained our model on the training data set. Do the predictions for the test data set. We can call knn.predict and pass in test, which is not seen by our model, and then pass into pred. So let's run this cell and get the predictions in pred. Print confusion matrix and classification report. So we need to do some imports again from Scikit-learn dot matrix import confusion matrix, and we can do these two imports in the same line, and let's print classification report and confusion matrix at the same time. So he's printing confusion matrix before classification report. So print confusion matrix and pass in y test and pred. The next one is we want to print classification report. Use tab for autocomplete, y test and pred. And let's run this cell here. And here we have the same results because we are using the same random state and same split. So the next task is using elbow method find the best value of k. You can either go back to the previous lecture and copy the code from there, or you can write your own code here. It should be very simple. Error rate equal to empty list, and then we can use for loop for I in range from 1 to 100, 1 to 100, and then we need to create an instance, pass in n neighbors is equal to I. Once we have created an instance, we need to fit on the training data set, and then we need to do the predictions. Pred I equal to knn dot prediction and pass in the unseen data, which is x test. So now we need to append the mean error if prediction is not equal to the observed values in y test. So err dot rate dot append. We can use numpy np dot mean pred I is not equal to y test. The error is only when we don't have prediction equal to test. Let's run this cell. So we don't get any error, the code is working. The next one is plot the error rate versus k to see which value have the lowest error. Let's recreate this plot. We can use plt dot plot and pass in x as range from 1 to 100 and our y is error rate. Let's run this cell, and here we have something similar plot. We can play with aesthetics to get the same plot in the output. So color is green here, and marker is circle, and then marker face color is, we have blue here, blue. And then if we see, he's setting k value as x label and error rate as y label. Let's set x and y labels now. plt dot x label k value and plt dot y label error rate. And one more thing, the figure size is different what we are getting in the output. So in the beginning, let's set the figure size as well. So plt dot figure and pass in fig size equal to, and this one is 16 and 6. And let's run this cell. And here we have the same output. The next question is, using k for minimum error rate, if we notice from the plot, we have the minimum error rate for k somewhere equal to 17. So let's use this k equal to 17 now in our model. So once again, k and n is equal to k neighbor classifier, pass in n neighbors equal to 17, and then fit on the train data and y train, and then get the predictions in pred knn dot predict, and pass in the unseen data, which is x underscore test. Let's print the confusion matrix and classification report at the same time. So print confusion matrix and pass in y test and pred, and then print classification report and pass in y test and pred, and let's run this cell. So here we have the same output. So we see it was worth trying the elbow method to get the optimum value of k. Our model is improved. So this was all about the KNN project solutions. Once again, I suggest go through these lectures again. Try to get as much as possible understanding on the KNN classifier or KNN machine learning algorithm. A very important message I want to convey here: always remember, the more data you have, the better you can train your model. So once again, this was all about KNN machine learning algorithm. Let's move on to the next lecture, where we are going to learn another very important machine learning algorithm with some real data sets. See you in the next lecture. Good luck.